So now we're going to learn about the intersection of two events. And so here's what a picture of the intersection of two events looks like. And I'm just going to move this over to the side. And I'm going to put this one over here on the right because I just want you to take a moment and pause this video and look through this terminology here and then kind of connect that to what's going on over here on the left. And so now so hopefully you paused the video and you thought about it. Now I'm going to explain it. And so we run experiments, and experiments have outcomes. And all of the possible outcomes is called a sample space. These are also known as the sample points in the sample space. And then we could define an event. And an event is a subset of the sample space. So we could say, hey, out of the entire sample space, where we do two rolls of a coin, here are all the sample points. But we might have one event that we want to figure out the probability for this event, where in this event we have at least one heads, or in this event we have at least one tails. So the event is a subset of the sample space, but the event could also be all of the sample points in the sample space. And so if this is our sample space here, this box right here, and we had two different events defined, event A and event B, the intersection of those two events is where they overlap, right? Like, where do these two events, event A and event B, have stuff in common? They share the same things. They have sample points, which are in both events. That's the intersection. And so to see what an intersection is, we have a little sample problem here. And we might, have this, we might look at this, and let me just bring this over actually, and I'll put it here, and then we'll put this one back up here so we can see them both side by side. But if this circle event A, so the sample space is 200 students, right? We have 200 students in this high school, and event A is all of the kids who are in drama club. There's 70 kids there. And event B is all of the kids who are in science club. We have 80 students there. Then the intersection of event A and event B, students who are in drama club is event A, students who are in science club are event B. The intersection of that is students who are both in drama club and science club. They're in both clubs. And so over here, given this problem here, right, these are the students in each, 70 in drama, 80 in science, and 30 in drama and science. So that 30 is like they're in both. And so if we wanted to know the probability that a randomly selected student is enrolled in both the drama club and the science club, so if we have 200 students, there are 30 students who are both in the drama and the science club. So again, just jumping to that logical conclusion, 30 out of 200, that's 15%. And how do I get to 15% so quickly? It's because I just want to think about, if I reduce this 200 to 100, I've divided 200 by 2. And so if I have this in the denominator and this in the numerator, if I divide the denominator by 2, I could divide the numerator by 2. And this becomes 100, and that becomes 15, or 15 over 100 becomes 15%, or 0.15. So there it is right there. But you can also see the explanation, which is given here in ChatGPT for solving this. And this is where I feel like statistics sometimes takes things which are simple and makes them a little bit overly complicated. But, here's how this is like kind of a logical framework for thinking about both the sample space, which is all of the sample points, all of the possible outcomes for an experiment, right? And then here's one event, which is a subset of the sample space. So sample space, all of the students. This one event A is they're in what did I say, drama club. This event B, science club, the intersection, both of them. So this is really kind of giving us a framework for thinking about, like, how are we figuring this out? It's not just like, kind of, I don't know, just guessing or kind of coming to that answer just through intuition or like what we already know. So it could help us if it's like a more complicated problem, maybe to think about it in a more structured way. But to solve this problem, you'll need to calculate the probability of the intersection of the two events, being in the drama club and being in the science club. So A is the event that student is in the drama club, B is that student's in the science club, the intersection, and this is how the notation is for intersection. A intersection B represents the students who are, and that's the symbol for intersection right there, that's the symbol. Represents the students who are in both the drama club and the science club. So calculate students in the intersection. The number of students in both clubs is 30. Calculate the total number of students, 200. The probability that A they're in both A intersection B, so that's the notation, is the number of students in both clubs by the total number of students, 30 over 200. And the probability that a randomly selected student is enrolled in both the drama club and the science club is that. And the problem illustrates how to calculate the probability of the intersection of two events, which represents the likelihood that both events occur simultaneously. So an intersection is having both events occur simultaneously, right? So simultaneously as students both in drama and science. And the intersection is going to help us, calculate some other stuff when we come down to like the union of two events. It could be helpful. And so here's a explanation from ChatGPT of the intersection of two events. The intersection of two events, A and B, denoted as A intersection B, represents the event that both A and B occur simultaneously. It includes only the outcomes that are in both events. Why it matters: the intersection is crucial for understanding the overlap between events, which is essential when calculating joint probabilities, or the probability that two events happen at the same time. And here's another example using the same die rolling example, which was up here, we'll see in a minute. If A is rolling an even number and B is rolling a number greater than 4, the intersection of A and B would include rolling a 6, and that's it. It's the only outcome that is both even and greater than 4. So again, can be a little bit of a convoluted way to think about stuff, but having sort of a structured framework for thinking about problems can maybe help us when we get into more complicated stuff. But that's the intersection of two events. And again, we're just kind of learning about boxes with circles in them. And the box is a sample space, and the circles are subsets of the sample space, and we call those events. And we could calculate the probability of an event. We could calculate the complement of that event. And we could also calculate the probability, or be interested in, or discover, or find, or somehow come to know the probability of the intersection of events, right? Like where things overlap. So that's the intersection of two events. See you in the next video.